Hello everyone, this is a video lecture for Calculus 3, section 12.6, 3D conics. So conics are basically your parabolas and your ellipses and your hyperbolas and stuff like that. Cool. But what I'm going to do now is I'm going to put them in 3D, essentially. So, it's going to be very difficult to draw some of these. Not that it's, I guess it's partially my lack of skill, as I'm guessing some folks are probably better than me. But it's also just trying to orient and see it in 3D, because in my eyes, I'm drawing it perfectly fine, but then maybe you're not seeing it. So I really think that the homework helps a lot because it has like color variations and it's shading it and stuff. Very nice. Even better is that if you were to go somewhere like on the internet and kind of like have a 3D like drawer or something like that. I know there's some programs that will do that. I just don't know them right now. So maybe like you can like rotate them and kind of see what it looks like. It's pretty cool. I suggest it. One last thing is that let me show you this right quick. It's sideways, I know, but these are pages in the formula book. And here's some more. And here's some more. And I don't really know if they were in the correct order or not. But essentially what we have here is we have a format, a formula format, I guess a template in a way. And then we have the shape that corresponds to it. And so I'm going to kind of cover these. I'm not going to literally go over these templates, I guess you can say. But I wanted to just show you that the formula book, even in Blackboard, it has these things, and it's very handy. Highly recommend it. And I'll be using it on a couple problems as we keep going. But let's just get going. 12,6,004. So they start with 6x squared plus y squared is equal to 6. And they want to graph it in 3D. Now, if you were to just take away the 3D aspect, and that's what I'm going to be doing a lot of times, if you were to remove the 3D concept, doesn't this look like it's two-dimensional? I mean, you got x and y. Where's your z? And so you can do this. This is actually going to be an ellipse, and I believe the major is a y. So there it is in 2D. Pretty easy. But what does it look like now in 3D, right? Well, here's the thing. X, y, and z. I'm saying that I'm missing the z. There's no z's. This was x and y, which if you can see, this is x and y right here. This is your xy plane now in the third dimension. So here, let me just draw it for you again. There you go. All I'm doing is taking this and putting it here. Okay? So then from there, well, z doesn't really matter. I'm saying that any z is equal to everything or anything, something kind of like that. And so it can extend up all the way as well as extend down all the way. And so what you have here is basically kind of like a, I don't know, like a roll, like a, I don't know, like a tube. There you go, a tube. Okay, so we got a tube. That's a technical term. Okay, let's keep growing. I'm going to try to use different colors, but ultimately it's not going to be perfect. Looking like someone just like sees this and they'll be like, what's going on? Well, it's that process that you saw me do it so that you can see it, kind of like what I was doing, okay? Okay, so I got 12,6,001. Z is equal to 6 minus y squared. Again, what is my x now? Well, it just doesn't, it's not there. So x could be anything. What I want to do is draw it in 2D, and then I can translate it to 3D here in a second. But I don't have an x, so how do I do x, y here? You don't. You choose different letters, and I'm going to choose y and z because those are what I have. This is my dependent variable, and that's my independent variable. At least it looks like that. So it's an upside-down parabola. There you go. So in 3D land, again, x, y, z for sure. See this YZ plane right here? YZ plane? YZ plane right there, okay? So let me redraw it for you. Parabola going down. Again, it's basically along that plane right here. And so, using a different color now, again, x doesn't matter, so I'm going to extend it out as far as I want. So there's some x, some negative x, and then what we're doing is we connect them. There we go. And then it'll obviously connect in the back right there too. What we've made is basically like a parabola. Oh, I know what I can call it. It's like a tunnel. There you go. It's like a tunnel where you can, I don't know, drive your car through. Beep, beep. It's a tunnel, essentially. I know, I'm just being silly. Next one. That's basically the entirety of this section. It's just going to be drawing, so and understanding what kind of shapes they are. So this one's kind of clever. Again, it's missing a Y, so I'm going to start with a 2D, and then I'm going to move to a 3D. But I need to make it into something different than this. So what about Z is equal to 6 over X? What about that? So if I were to draw this in 2D land, again, X and Z, you have to kind of make these up as you go. It would be a reciprocal function, just like that. So now in 3D land, X, Y, and Z, that XZ plane is right here. You see it? XZ plane. And so I would draw this, and the negative down here would be over here. See it? So I just kind of moved it over. Again, I want to show you more like what's going on. Well, Y doesn't matter, therefore Y could be anything. And so you got a lot more Y's going on. So it's kind of like a skating ramp. And then down here, the same kind of thing. You would just have them go down. There you go. So it's kind of like a skate ramp. Whoosh! I'm going to call it a ramp. There you go. Very technical terms here. That was a joke. These are not technical terms. Okay, next one. 12.6.013. So now we're really breaking into those formulas, those templates I was showing you earlier. X equals y squared plus 6z squared. You could set this equal to, like, set some of them equal to 0 and then see what you're going to get. Like, what if I just said x is equal to 0? Then I could look at this and draw it accordingly on the YZ plane. So this would be your YZ plane shape. And then I could just set y equal to 0 and draw it again. And all these things you can do equal to 0 in each case, but I think that we can use our templates to help us out. So I'm looking for a template that makes sense with this, and if you look around enough, you'll see that this does not have a square right here. Sorry, let me draw it a little bit better. There's no square right here, okay? There's an equal sign, and you got two other squares. There's a plus sign right here. Okay, these are indicators that this is an elliptical paraboloid. I cannot spell it, but let me pull it back up. Elliptical paraboloid is this guy right here. Look, we got, I know it's sideways, I'm sorry, but we got this single letter without a power 2, and we got a plus sign between the two squares. Now, I'm not concerned about A and B. That's not what I'm talking about. I'm just saying, hey, we got, you know, a lacking a square power there and a plus sign. Here we go. And so it's just basically a parabola, but it's like it's like a cup is what it is. It's a cup shape. And so let's draw it. Some things to learn, that's what the section's about, is learning, is that there's this thing called the odd man out. The odd man out. That is definitely not a technical term. That's a Chad term. I'm Chad, hello. And so odd man out basically is the one that mostly you're going to be rotating around with your axes. Maybe he's the axes that is like its center, perhaps. Lots of different things that come with the odd man out. So what you're looking at, let me redraw it right quick. Looking here, X, Y, or Z, which one's the odd man out? It's definitely X. And so in this particular case for the elliptical paraboloid, that's your axis of rotation. So it'll be spinning around the x-axis. So let me try my best here. basically I have this parabola coming out right here towards the x, but it's also coming out this way up and down. And so what it makes is like a circle cup shape. This is a cup, but it's sideways. Okay. So there you go. Ta-da. I know it's not perfect, but that's, well, I try my best. Next one, 12.6.015. So I got x squared is equal to 36 y squared plus z squared. And I'm looking to see what kind of shape this is. Again, you can go back and look at these things. I'm not going to do this every time. It's actually a cone, because really what's going on is that when this moves over, you have something plus something equals something. Some things to note is that they're all squares. So that's kind of, it tells you at least where you're going. There's no constant. So no constant. That's the biggest indicator that it's actually going to be a cone. Okay, now again, who's the odd man out? It's your x, for sure. Everyone can see x is the one that's a little different than the rest because he's on the other side over here. Or if you were to go back to your template for the cone, who's the odd man out here? It's z, because he has got a negative in front of him. So there's not like a proper definition for odd man out, but it's the one that's different than the rest. So these guys are added together, everything's fine. He's separated from them. So x is going to be my axis of rotation, or where it's kind of centered, or whatever you want to call it. Let me show you. X, y, and z. I have a cone. X is going to be where it's going to be circling around. There you go. Ta-da, we're done. If you want to be more like straight up about it, there's actually another side over here. Cones always come in doubles. But there you go. There's my cone. Next question. I mean, you're just clicking multiple choice. Which picture is it? What is its name? All that kind of stuff. Oops, I was writing it incorrectly. That is a z squared. And then it's an x squared. Okay. So I'm looking around my paper and I'm seeing which one is it. Well, first off, odd man out is actually this guy. That's the odd man out because he does not have a square. See, it doesn't have a square. I know there's a minus sign between there, but that's just going to be indicating which one of these hyperbolics we would have. So technically this is a hyperbolic paraboloid. It's fine. Hyperbolic paraboloid. A way better term for this is called a saddle. It's called a saddle. There is very difficult for me to draw a saddle, but essentially it kind of looks like this, and then that would kind of go down there. It's a saddle where you're sitting on it, and it kind of comes up on both sides. Okay, so that's a saddle for you. Actually, I drew that pretty well. I am not going to draw this one pretty well at all. So X, Y, and Z. Odd man out is Y. Y is going to be actually that, I guess you can call it like the center, or where it's all revolving around. And it's kind of weird because the saddle involves two different kinds of parabolas. So what we have here is a parabola that's doing this for Z. This is along the ZY plane here. And then at the same time, I have another set of parabolas here that are on the XY plane. So it's coming down on the X, but it's coming up on the Z. And why is that? Because this is a positive Z and a negative X. Okay? So that's how I'm knowing which way they're going to go. Normally, I just leave it like this because honestly, it's very difficult to draw. But I will try my best. Basically, you have a lot of these little parabolas here. You got little parabolas here. And then you're kind of like connecting them. So something kind of like this maybe. And then you have a whole other sheet back here. There you go. That's actually not too bad. So again, it's a saddle. And, well, it's kind of weird because you'd be sitting it here, and so your head's coming up right there and you're looking that way. Kind of weird. Moving on. Saddle. Best I could do. Click the one that looks like a saddle. I've got 12, 6, 0, 2, 4. And so I got 9x squared plus 4y squared plus z squared is equal to 1. And I'm going to ask you, who's the odd man out this time? Do you see him? There is none. Squared, 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 all positive. Oops. All positive. No odd man out. So what this is an ellipsoid. Ellipsoid. And so, like, you know ellipses. Well, now an ellipsoid is just going to be in three dimensions. You're trying to also find your major minors, I guess, in a little bit. What happens is it's the opposite of the big numbers. So you can see I got a 9 right here. This actually makes the x's really small in the end. While this guy here has only got a 1 compared to everyone else, so he's going to be bigger. So if you had to pick a major, it would be this guy. Again, it's not really super critical, but it's important to draw these correctly. So I'm going to have a whole lot of z. I'm going to have some y's, and then I'm going to have very little x. Okay, so what I do is I start to draw on the planes, and so I could draw this one here, and then we could draw this one here. But essentially what you're doing is, well, you're drawing a football, so there's your football. Okay. I want red. Next one, 12, 6, 0, 25. So x squared minus y squared plus z squared equals 1. Again, you can go back to that template, but notice that who's your odd man out? That's your odd man out right there, the only one with a minus sign. So that's good. There's something else is that you only have one minus sign, and so then it's going to be a hyperboloid of one sheet. One minus sign, one sheet. If you had two minus signs, which I'll show you in a second, you'll get two sheets. So one sheet, basically it's like a wormhole, but keep in mind that your y is your odd man out, so you'll be going around your y, and it's kind of does this. So it's kind of like a wormhole. You go in and you come out. There you go. 12, 6, 0, 26. Ooh. Of course, I got to name each one of these. Not that it matters. I got a negative x squared plus y squared minus z squared is equal to 1. So I'm asking you, who's your odd man out? It's actually the plus sign guy. This is your odd man out. But notice that we have got two minus signs. Thus, you're going to have two sheets. Two sheets, two minus signs. Again, y is your odd man out, so he's going to be your axis for rotation and all that kind of stuff. So it's kind of harder to draw this one, but basically you have a cup over here, and then you have a cup right over here. So two different cups. If you were to put this in two-dimension land, it would look like this, of course. Looking at it from right here, there's your camera. That's a camera. Like an old-timey camera. Viewing this way. So you would see these two cups, or again, a hyperboloid. So one sheet, two sheets. I don't know. I'll just call it two cups. There you go. Keep going. 12.6.028. I got y squared is equal to x squared plus 2z squared. Who's your odd man out? It's the y. And notice that they're all squares, but I have no constant. And no constant is a big indicator of a cone. It's a big indicator of a cone. And so y is your odd man out. Seems that happens a lot right now. So cone. Cone. There you go. It's proper to do both. All right, last one. I was actually not going to do any more, but this one was a little different than the others, and I wanted to do it with you. So x squared plus y squared minus 2x minus 6y minus z equal plus 10 equals 0. There we go. They want to write it in standard form, and then we can graph it. So write it in standard form. And so first off, get that z over here, and you're going to complete the square with your x's and y's. So x squared minus 2x plus something minus something, y squared minus 6y plus something minus something plus 10 equals z. Okay. You take this number, negative 2 over 2 is a negative 1. Negative 1 squared is a 1. So I'll do that here in a second. Here, I got negative 6 over 2 is a negative 3. Negative 3 all squared is a 9. Cool. So this number is going to go here and there. We're going to go here and there. 1, 1, 9, 9. And this is your perfect square. So keep going. I got x minus 1 squared minus 1. Y minus 3 squared minus 9. Whoa. Almost forgot it again. Plus 10 is equal to z. We're very close. Notice that we got negative 1, negative 9, and a positive 10. These actually all cancel out, leaving you with this one and this one. So that's your standard form. I would write the entirety of that in that box. But what is this going to end up being? Well, notice that you got your odd man out, yes, but he also doesn't have a power. So he's a power 1, essentially. This is going to be a paraboloid, like a cup, basically, a 1 cup. And so there's something about this, though, is that it's been shifted. I'm shifting it down x1 and shifting it down the y-axis 3. So this is your point where you're touching, and then you make your cup, essentially. So, cup. All right. That's all I got. So, that's been fun. Thank you very much. Have a great day.